Welcome in the next lecture of several variable calculus. We are in second chapter, partial derivative and differentiability. In the previous lecture we solved some problems on chain rule case 2 and general version. In the today's lecture we have to discuss the homogeneous function and Euler's theorem. So we start our topic homogeneous function. In a previous year also we discussed the homogeneous function for the one variable function, and in this year we have to discuss the homogeneous function for two or more than two variables. So we write the definition. Let f be a function of two variables x and y. The function f is called homogeneous of degree n if it satisfies the condition, the condition. Which condition? That is f of tx ty is equal to t raised to n f of xy for all t, all real t, and where we can say n is a positive integer. So it is n is a degree, therefore it is a positive integer. So what we wrote definition, f is the function of two variables, then it is a homogeneous of degree n if f of tx ty is equal to t raised to n f of xy for all real number t, where n is a positive integer. For example, suppose we have a verify f of xy is equal to x cube plus 5x square y plus y cube is homogeneous or not. If yes, find degree. Find the degree of this. So what we have given? Given that f of xy is equal to x cube plus 5x square y plus y cube. Now what we can do here? We have to put x is equal to tx and y is equal to ty. Okay, x is equal to tx and y is equal to ty. Then what we are getting? X f of tx ty is equal to, it is equal to what? X cube means x tx cube plus 5, it is what? Tx square ty plus ty cube. Now do solve this. So what we are getting? T cube x cube plus 5 t square x square into what? Ty plus what? T cube y cube. And now if you simplify this, here is again t square into t is t cube, so you can take common t cube, so it is x cube plus 5x square y plus y cube, and this is our what? This is our f of xy, so it is t cube f of xy. Therefore what we have given? what we are finding, f of tx dy is equal to t cube f of xy. Therefore what we can say, therefore f is of homogeneous function of degree, which degree? Degree 3. F is a homogeneous function of degree 3. Similarly, you can check it is a homogeneous function or not. So Euler's theorem, what is our Euler's theorem? So Euler's theorem we have to write. Let f be a two variable function which is homogeneous of degree n, and f has a continuous second order partial derivatives, then what we can say, x dabba f by dabba x plus y dabba f by dabba y is equal to n into f of xy. So this is our statement. Okay. So what we have to write? Proof. So what is given? F is a two variable function and it is homogeneous of degree n. So what is given? Given f is homogeneous of degree n. Hence what we can write? Therefore what we can write? F of tx dy is equal to what? T raised to n f of xy. Say this is equation number 1. Now put u is equal to tx or v is equal to dy, or we can say you write down this u and write down this is v. So what we are getting? This is nothing but uv. F of uv is equal to t raised to n f of x f of y. Say this is equation number 1 and this is equation star. Okay. So what we can do now? First we have to differentiate equation 1 with respect to what? X. We have to differentiate with respect to x. So differentiate this equation 1 with respect to f. Dabba f of uv upon dabba x is equal to t raised to n is constant. So it is dabba f of xy by dabba x. So now here is a f is function of uv and uv is function of x. Therefore you have to use here a chain rule. So dabba f by dabba u into dabba u by dabba x, it is equal to t raised to n dabba f by dabba x. Now what we can find? Dabba u by dabba x. What is dabba u by dabba x? This is dabba u. So dabba u by dabba x, it is t is equal to t raised to n dabba f by dabba x. Now do simplification. What is dabba f by dabba u? Dabba f by dabba u, it is equal to what? T raised to n upon t into what? Dabba f by dabba x. And therefore what we can write? Dabba f by dabba u is equal to t raised to n minus 1 dabba f by dabba x. This is equation number 2. Now similarly we can find what we have to find? We have to find dabba f by dabba y. Okay, so again differentiate equation 1 with respect to what? What we can say, it is y. So Here delta f of uv by delta y, it is equal to t raised to n delta f by delta y. Now what we say, f is function of u and v, u is function of x only, but v is function of y. So you have to use again a chain rule, delta f by delta v into delta v by delta y, it is equal to t raised to n delta f by delta y. Now what we are getting, delta f by delta v and delta v by delta y, delta v by delta y, it is again what? It should be t, it is t raised to n delta f by delta y. Now if you are simplifying this similarly above, it is equal to what? T raised to n minus 1 delta f by delta y. This is equation number 3. This is equation number 3. Now what is our target? Now we have to differentiate equation 1 with respect to t. Now we have to differentiate this equation with respect to t. Now here what? U, f is function of u and v, and u and v are the function of t. Therefore we have to use again here a chain rule. So how we use delta f by delta u and delta u by delta t, that is f is function of u and u is function of t, plus delta f by delta v into delta v by delta t. Again f is function of v and v is function of t. It is equal to what is the derivative of t raised to n? N into what? T raised to n minus 1 into f of xy, into f of xy. Now just put the values of equation 2 and 3. So put equation 2 and 3 in equation above. So what we are getting here, delta f by delta u, t raised to n minus 1 delta f by delta x into delta u by delta t, delta u by delta t. So what is delta u by delta t? It should be what? X, plus again what is the value of this? T raised to n minus 1 delta f by delta y into delta v by delta t. It should be again y. It is equal to n into t raised to n minus 1 f of xy. Now what we have to do here? Only divide by t raised to n minus 1. Divide both the side by t raised to n minus 1. Divide both sides by t raised to n minus 1, and then what we can get? All this t raised to n get cancelled. Therefore x delta f by delta plus y delta f by delta y, it is equal to what? N into f of xy, n into f of xy. Okay. So in the similar way, that means what we can say, it is very easy, just you have to differentiate with respect to x, with respect to y and with respect to t, and put all this equation number 2 and 3, that is the value of delta f by delta u and delta v by delta f by delta v in the given equation, and divide by t raised to n, you will get the answer. Now we will go for the Eulers Theorem corollary. Now we write a corollary. So what we have? F be a function, let f be a homogeneous function of degree n, and what we can say that, and f has a continuous second order partial derivatives, f f has the second order partial derivatives, then what we have to prove? Del bar square f by del bar x square into x square plus y square del bar square f by del bar y square plus 2xy del bar square f by del bar x del bar y. It is equal to n into n minus 1 del bar, or what we can write, f of xy. F of xy. Now we prove the corollary using Eulers theorem. So from Eulers theorem, so what we write here from the Eulers theorem, we have x del bar f by del bar x plus y del bar f by del bar y. It is equal to what we have written, n into f of xy. Say this is equation number 1. Now differentiate equation 1 with respect to x. Again we have to write similarly. Now here is both the functions are product of the x functions of x. So you have to use here product rule. So what should be this? X into del bar square f by del bar x square. X derivative of x is 1, so del bar f by del bar x plus here. Now you can write y is constant, del bar square f by del bar x del bar y. It is equal to n into what? Derivative of this, del bar f by del bar x. Now multiply by x. So what we are getting here? X square del bar square f by del bar x square plus x into del bar f by del bar x plus xy del bar square f by del bar x del bar y. It is equal to what? N into x del bar f by del bar x. Now what we see here, these both are the like terms. So we can do simplification. X square del bar square f by del bar x square plus xy del bar square f by del bar x del bar y. It is equal to, so what we can write here, it is n minus 1 into x del bar f by del bar x. Say this is equation number 2. Okay, so this is n and this is minus 1, n minus 1, x is common, del bar f by del bar x is common. This is equation number 2. Again we have to differentiate this equation with respect to y. So differentiate equation 2 or 1 with respect to y. Similarly, now here what we can see, here both are function of x, but here we can say this function, this f is function of x and y, but here y and del bar f by del bar y both are function of y, so we have to use here product rule. So here x is constant, del bar square f by del bar y del bar x, we are written derivative of this. Now here is product rule. So what can we write here? It is derivative of y is 1 into del bar f by del bar y plus y is constant now and it is del bar square f by del bar y square. It is equal to n into del bar f by del bar y. Now what we can do here, again multiply by y. So what we are getting here, x into xy into del bar square f by del bar y del bar x plus y into del bar f by del bar y plus y square del bar square f by del bar x square. It is equal to, it should be y square, it is ny del bar f by del bar y. Now these two terms are like terms, so you have to use again simplification del bar square f by del bar y del bar x plus y square del bar square f by del bar y square, it is equal to what? N minus 1 into y del bar f by del bar y. Say this is equation number 3. Add equation 2 and 3. So adding equation 2 and 3 we get. So add this, what we are getting? X square del bar f by del bar x square plus xy del bar square f by del bar x del bar y, it plus what should be this? Xy del bar square f by del bar y del bar x plus y square del bar square f by del bar y square, it is equal to what? N minus 1 into what? X del bar f by del bar x plus what? N minus 1 y del bar f by del bar y. Okay, so what we are getting here, what we need, it is in the here n into n minus 1 into f of xy. Okay, so what we can write here now, this is our x square del bar square f by del bar x square plus, now we have a second order partial derivatives are continuous, therefore these mixed partial derivatives are equal, therefore 1 plus 1 is 2xy del bar square f by del bar x del bar y plus y square del bar square f by del bar y square. N minus 1 is common, then what we are getting? N minus 1, then we are getting x del bar f by del bar x plus y del bar f by del bar y, and y it is here del bar square f by del bar x del bar y is equal to del bar square f by del bar y del bar x, as if second order partial derivatives are what? Are continuous. Okay, it is continuous, and therefore what we can write, what we see, we are getting our left hand side, but in a right hand side we see that this is nothing but our Euler's theorem statement, or it is Euler's theorem equality, which side? Left hand side. So what should be written here? By Euler's theorem, x square del bar square f by del bar x square plus 2xy del bar square f by del bar x del bar y plus y square del bar square f by del bar y square, it is equal to, it is, what is the value of this? Value of this is n into f of xy, so n into n minus 1 f of xy, and this is our required solution. Okay, so in the similar way we can solve so many problems. Suppose we have given a function f of xy, and they are saying verify it is a it satisfies the Euler's theorem or this inequality, Euler's theorem corollary inequality, then you have to just prove, you have to just find out these partial derivatives, put this value, you must got a left hand side and right hand side are equal. Okay, so just try to solve the problems taking a function f of xy. So what we see today, homogeneous function, Euler's theorem, and one corollary on Euler's theorem. So we have to solve some problems in the practical session, and then we finish this chapter. So thank you very much.